What is Java's comparable interface? When should you implement this interface? And what are the benefits of comparable objects? Hi everyone, welcome back to Geolytics Learning. The comparable interface contains a single method, compareTo, that returns an integer. This method determines the natural ordering of class instances. For example, if you call object1.compareTo object2, the method should return 0 if object1 equals object2, a negative value if object1 is less than object2, or a positive value if object1 is greater than object2. You should consider implementing the comparable interface in your class if there is a notion of natural ordering in your class instances. Let's take an example of a circle class. We define a private field radius to store the radius of a circle. We provide a constructor that takes a double value representing the radius of a circle. We also define a default constructor that initializes a circle's radius with a value of 1. Notice that the default constructor calls the other constructor to avoid duplicated statements. In programming, it's always a good idea to avoid duplication and keep your code concise. Now let's create some getter methods that return the radius, area, and circumference of a circle. We also need to override the toString method to get a meaningful representation of a circle's object, which is useful in testing and debugging. To test the circle class, let's create a main class. In the main method, we start by creating an instance of circle C1 and print it. As you can see, the default constructor works as expected. It creates an instance of circle with a radius of 1. Let's create a couple other circles with different radius values. We are going to put these circles into a list. Recall that as part of best practices in using Java collection framework, we should always specify the type of a list using the diamond operator. In this example, we define a variable circles of type list of circle and create an array list of circle. List is an interface. Array list is a concrete class that implements the list interface. When we run our main class, it prints the list of circles in the order of addition, which is C1, C2, and C3. The Java collection framework provides useful methods that allow us to sort and shuffle elements within a collection. These utility methods are available as static methods in the collections class. Let's try to sort our list of circles. Unfortunately, we cannot sort our circles because they are not comparable. For the sort method to work, the elements of a collection must be comparable. Or we can also pass a comparator object that determines how the sort should work. In this video, I will focus on making our circle objects comparable. Since circles have the notion of natural ordering, let's implement the comparable interface in our class. We state that the circle class is comparable to another circle. When we add this statement, IntelliJ automatically gives us a warning, an option, to implement the method defined in the comparable interface. Recall that an interface defines a set of methods that must be implemented by a concrete class. The comparable interface only defines a single method, compareTo, that takes a type of object and returns an integer. In this case, compareTo takes a circle object and returns an integer. How should we implement this method? Let's review the Java API specification. We can look up information about the comparable interface. This interface specifies the natural ordering of a class in its compareTo method. The compareTo method should return a negative integer if this object is less than another object, 0 if they are equal, or a positive integer if it is greater than another object. If compareTo null, the method should throw a null pointer exception. First, Let's check the given argument to ensure that it's not null. If it's null, we throw a null pointer exception. Then, we continue with a conditional statement to compare the radius of this circle with the given circle following the specification of the comparable interface. If the radius of this circle is the same as that of the given circle, return 0. If it's greater than the other radius, return 1. Otherwise, return -1. Back to the main class, the sort method can now take the circle list and sort its elements by radius. Let's do additional testing to make sure that the compareTo method works according to the specification. First, if we pass null, this method should throw a null pointer exception, which it does. Then, we can call the method to compare circles with different radius values. Here, we create a conditional block statement to compare C1 and C2. Since C1's radius is 1 and C2's radius is 5, C1 compared to C2 returns a negative integer and the last else is executed. We can modify the conditional statement to compare C3 and C2 and C3 and C1 to check the correctness of our compare method. Finally, let's see if the method returns 0 if the compared objects are equal. Make sure that your tests cover all possible return values of the compareTo method. We can automate such tests by writing a unit test code using a testing framework such as JUnit, which I will cover in a separate video. Many Java objects are comparable and provide methods that work like our compareTo method. In the circle class, we compare two double values. Java has a wrapper class for double values, which not surprisingly is called double with a capital D. And let's see the documentation of this double class. The class has a static method named compare that takes two double values and returns an integer. When comparing D1 and D2, it returns the value 0 if D1 is equal to D2, a negative integer if D1 is less than D2, and a positive integer if D1 is greater than D2. This behavior is what we need exactly to implement the comparable interface in our circle class. So, we can replace our conditional statement with a call to double.compare method, which makes our code more concise and more straightforward. If you like, you can go back to the main class and experiment with the test code to ensure that the compareTo still works correctly. Some key points from this video. First, consider implementing the comparable interface in your class if your class has some sort of natural ordering. In this example, we use radius as the natural ordering of our circle class. Second, the comparable interface defines a single method, compareTo, that returns an integer. This method should throw a null pointer exception if given null. Otherwise, it should return a negative integer, 0 or positive integer depending on whether this object is less than, equal to, or greater than the given object. Third, some benefits of comparable objects are that they can be sorted in a collection and that they can be stored in a data structures that requires order, such as TreeMap and TreeSet.